The chain rule is something that we start off early in calculus, but it's the hardest thing we've come upon yet if you're not careful with how you conceptualize this thing. Okay, now we've done things where you can find the derivative of things that are multiplied with the product rule, and things that are divided you can find with special quotient rule. And we've proven a lot of these, but applying them is the point, because we're trying to figure out how to do this math. And the chain rule is another situation where you are looking at two functions like this, but instead it's functions within functions. And so you're going to see it written like this. And if I want to take the derivative, now we're going to call it d dx. And it's going to be written this way, which will be confusing. But nonetheless, this is how it's written. And what it means is you take the derivative of the outside function, you maintain the inside function, and then you take the derivative of the inside function and multiply it through. So let me give you an example. Okay, if I have the square root of x to the fifth plus 1, we have an inside function. In fact, I'll rewrite it right away like this, because that's what it really is. If I want to find the derivative of this, we're going to take the derivative of the outside. So I'm just going to bring the exponent down because it's an exponent rule like this. And I'm going to keep the original. Then we're going to multiply by, see it here, the derivative of the inside. So in essence, we're doing these separately. So what I'd end up with here would be 5x to the fourth over 2 root x to the fifth plus 1. And that would be the answer for this particular problem. Let's try another one. Let's see if we can just do a couple of examples here and figure this out. Let's do e to the sine of 2x. Now, be careful, because there's an outside function, an inside function, and an inside function. Okay, so if I want to take the derivative of e to the x, it's going to be e to the x, so that's the original, no changes really, times the derivative of the inside function, which would be cosine 2x, except times the derivative of the inside again. This is another inside. So there's a times 2 here. Are you seeing it so far? This is all that's necessary to understand, which is that you take the derivative of the outside, you keep the original inside function, and you multiply by the derivative of the inside function next to it. And you keep chaining those insides into the next spot until you're done. Let's do some practice problems and give it a try.